Hello, everyone. How are you today? Welcome, everyone, to this our second session of our Hack Week. Um, Welcome today to our second session of Python scripting. Welcome to this night, evening, morning. I don't know which time it's where you are. So yeah, welcome to our second session of our Python scripting. We're learning how to use Python for cybersecurity, how to learn some things like hashing, like encryption, and things like that, and how we can use Python to do some cool stuff with this. So welcome today. Before doing this, we're going to, I want to have, or give a little ad for all the students that are on the stream. So yeah, let's first see the GitHub Student Developer Pack, and also let me see if I'm on stream. Let me know if you can hear me well, if anything happens, So let me just open the GitHub student developer pack. This is going to take just 5 minutes. So if you're a student, maybe this is going to interest you. So if you were not on the last session that was yesterday at the same hour, don't worry about it. You're going to learn something real cool right now. So let me share my screen and share the GitHub student developer pack. And let me go again, and I'll just so yeah, I think now you can see it. So yeah, welcome everyone. We're going to see some things about the GitHub Student Developer real quick, so don't worry about it. So yeah, the GitHub Student Developer pack. If you're a student, if you're a teacher, maybe you can have this pack. So the GitHub Student Developer pack is basically like a digital backpack that all the students have, no matter if you're in an institution like college or university, or if you're in a boot camp in high school, you can have this pack. And basically, this pack gives you a lot of things like a virtual event kit, Python cloud, acquiring credits. You have code spaces, carry readiness into web developer. Also, you can learn a lot of data science and machine learning. So you have a lot of tools, a lot of free stuff that you can claim. Like for example, if you want to make a portfolio and you want to give it like David.me or David's portfolio.me or something like that, you can use your domains that you have, like Namecheap, like name.com, tech domains, and also GitHub has a lot of free domains that you can use. If you want to build some cool apps in the cloud, like I don't know, maybe like digital auction, you want to make a cool application in the cloud, you can use some free stuff like digital auction, like Microsoft Azure. You can use Heroku for your APIs and things like that. So it is real cool. It is so great. So I'll suggest you to go in right now, and if you have an educated account, it will help you to obtain your student developer pack. If not, don't worry about it. This is real easy to do it. For time to GitHub student developer pack, you just need to just let me sign out from my account. You can join your global campus, and for that, you just need to say that you're a student. So you say, hey, I'm a student, and it will ask you to add like information about like if you have an email or like an educated email or an ID from your school or things like that. So don't worry about it. This is really easy to obtain. Maybe just 30 minutes you have access to it. And also you have access to Global Campus. So if you're a student and you have built already your application and you want persons to help into this is really great because you can help everyone like this open source project. You can help to contribute to the open source projects that you have here, like misuse that it's basically I don't know what this is, but it looks real cool. So yeah, you can contribute to all the open source projects that the community exchange has. Also, there are authorships. If you will need more information to authorships, let me share it with you. So basically, our authorships are like the fellowship, like the MLH fellowship by GitHub. So basically, you have access to apply to a company that is helping students around the world in some countries like Mexico, Colombia, Nigeria, and things like that, like India also. And if you want to learn by doing, I totally recommend you to apply to an internship. Maybe well, you just need to complete some tasks that the company gives to you. Like for example, hey, if you want to contribute to NPM, hey, can you fix this bug that we have right now? And if you can fix it, maybe you will be in, right? So you have a lot of things that you have as a student with the GitHub Resilient Developer Pack. So I totally encourage you to climb your student developer pack. You can build your portfolio. You can learn data science. You can learn if you want to prepare for your technical interview. You have auto expert. You have educated. If you want to learn data science, you have data camp. You have 3 months of data camp. You have access to Visual Studio. You have access to really cool things that we have. That you're going to see right now in the stream that is called GitHub Code Spaces. That basically is like an IDE that you have in the cloud. So I don't know if this happens to you, but if you don't have like a totally computer or thing like that, my name. Oh, sorry for that. Let me see if I can configure this a little bit. Uh, Give me a minute. I don't know if it's my international collection, so let me know if I'm. So, by this you can hear me better. Let me know if this is better for you or if there's still some lag into my audio. Uh, if not, uh, right. So, is now better? Let me know in the comments if now it's better or is the same or anything like that. Uh, so yeah, while we wait for that, let me tell you about the GitHub Code Spaces. So let me put here Code Spaces and uh, now I think you can see it. So yeah, so you can start coding instantly with code spaces. Like I don't know if you have this situation where you don't have like a real powerful computer or things like that. So GitHub gives you like a virtual environment where you can work anytime, wherever you are with whichever computer. Like everything is in the cloud. You will have your own space, like your own IDE that you can claim just a minute. So like I said, this is really cool because you have all your ID, like all the things that you have into your computer. Like if you were coding a web page, if you were coding Python or anything like that, all the programming languages are already installed. A lot of packages are already installed, so you don't need to do anything. It is on Linux. You have, as a student, you have unlimited time to use GitHub Code Spaces. So yeah, you can personalize it like however you want. It is basically a Visual Studio Code, but in your computer or like in your browser or wherever you are. So yeah, totally use it. We're going to use it for our session today. So yeah, let's continue with this. Let me go again. And so if you were yesterday in our session, um, let me share my screen again to just share the slide. Share screen and all right. So yesterday we learned about the Python fundamentals, and now we're going to learn something about hashing and encryption. So for this hour, we're going to learn things about hashing, the art of securing data. We're going to learn things about what is hashing process of using a hash function, and a hash algorithm, and the hash algorithm, SHA, the one hash algorithm, is it SHA 256 hash algorithm. And yeah, we're going to look up at all the things. Yesterday, we learned some things like basic Python functions, how to manipulate strings in Python, how to handle files in Python. And also we learned, I think that was all. Like we saw some examples uh, about handling things. Like, let me share my screen again, just to go into our project that we did yesterday. So let me go to my profile, and after going to my profile, let me open the project. Just give me a little bit of time. No, security week, and with the security week, let me open the code space that we have here. Mm, and yeah, which is a cool thing about GitHub code space is that it gives a really random name to your code space, like pizza, guacamole, or fluffy stuff, or fluffy space, or things like that. So yeah, now you can see code spaces. Code spaces like Visual Studio Code, but in your browser. So you're not going to use any kind of resources from your computer. Everything is being processed in the cloud, like on the servers of GitHub. So don't worry about anything. If you don't have like a real powerful computer and you want to create it like a really web page, a real really web app, or process some data or things like that, everything is going to be processed into the cloud. You don't need to use any kind of resources from your computer. And yeah, so yesterday, like I said, we learned things about Python, like basic kinds of functions, how to open files, how to handle files, how to manipulate strings and things like that. Also, we learned how to create a virtual environment, how to create a git ignore, what a git ignore was, and we did an exercise with this file that basically helped you to understand how to use Python for manipulate all the strings, and we convert all the strings into our dictionary with all the information that we need. Yeah, so after this, let me go here and let's start with hashing. So what hashing is? So hashing is the process of converting data of any size into fixed size output, typically of a string of characters in cryptography. Hashing is used to ensure the integrity of and authenticity of digital information by creating a unique digital fingerprint of data. So the purpose of hashing is to provide a secure way of verifying that the content of a file or message has not been altered in transit. So by comparing the hash value of the original data with the hash value of your received data, it is possible to detect any changes that may occur during transmission. So yeah, it can help you a lot to, if, for example, if you have a string that has really information data, like maybe the password of your bank account or anything like that, you can use hash algorithms to modify that string into like a really great string with random information or random characters that are made by the hash algorithm. So later in the stream, we're going to see some of those algorithms, so don't worry about it. So after this, some of the great properties of a good hash function are like a good hash function should have several important properties, including collision resistance, image resistance, and the avalanche effect. Collision resistance means that it is difficult to find two different inputs that produce the same output. Pre-image resistance means that it is difficult to find an input that produces a given output. And the avalanche effect means that a small change in the input should result into a significant change in the output. So we're going to see some cool things right now. So for example, if we use a hash function to store passwords, we want to make sure that even if two users choose the same password, their hash values will be different. So this prevents attackers from easily guessing passwords based on their hash values. So additionally, we want to make sure that if an attacker obtains the hash value of a password, they cannot easily determine the original password of the hash value. So let's see a really cool example about hashing right now. So let me go again to the code spaces. So imagine that, let me see if you're seeing now the screen. Yeah, you see it. Also, let me know if this size is good, or if you need to make it, you need me to make it a little bit more bigger so you can see it. So yeah, let's start with this. So by doing this, we're going to see an example of a really cool hash. Like, let's imagine something like secret message, and this is going to be equal to, hey, this is a secret. Hey, this is secret. So imagine that we are going to have this string. So what I want to do by hashing is to convert all the string into something real different. There are a lot of algorithms and well, there are a lot of hashing algorithms. One of the most popular one is someone called SHA 256 or 250. This algorithm should, if we run this algorithm into this string, we will want to see something like this. Like as you're seeing, this is real big, and this is a hash value. And even if you modify, like, remember the avalanche effect that we saw before? Like, a little change into our original string should produce a different or like a big change into the value. So even if we add just one white space into our original secret or secret message, we will see that it will print out something real different, right? Like I mean something like this. So see, this and this are real different. And the other thing that we changed was adding white space into our secret message, right? So Python allows us to run some of these algorithms into our string. So I think we just need to install something called so let me give me a minute to search the name of the Python library. So let me ask ChatGPT how to install SHA into Python. Um, So right now I'm just searching it. So the name of the library is called hashlib. So import hashlib. And I don't know if we have already done this, so let me enter also to my virtual environment. So first, my amp being activated. And now we are in the virtual environment. So let me install on the library, install hashlib. And right now, I think it is installing. So let me see what's going on. Set up the time. All right. So let me see what this is. So hashlib. So all right. So I think it doesn't allow me to me. So let me see if it is because we're running in Linux. So let me see if I can change this. I just installed like how to install it. How can I install it in RPM? Okay, so Python dev. Open it. All right, so it should be the same thing, I think. So I don't know if I need some kind of administrator. No, it's the same thing. All right, so no, all, please verify. What is this? Oh my God, this is big. I was not prepared with that. So let me see if there's another alternative. Is there an alternative to build to library? What? All right. This is for hashlib too. Okay. So put install hashlib too. No. Okay. Let me go into the. So let's see what are we seeing right now. So let me stop sharing this and share my total string so we can debug this. So just give me a minute. So Oh my god, I almost closed the stream. So check your connection. Sorry for that. Like my internet connection right now is really dying. So sorry for that. Please always let me know if you're like hearing me like really laggy or anything like that. Please let me know it. And also let me check my ping. I haven't even checked my ping. So let me see ping on here. Uh, yeah. Well, I mean, it's not that bad right now, but always like again, always if you're hearing me real laggy, let me know it. Mm, and yeah, so I think yeah, now you can see me. So we're seeing this error that we're looking at. So we have unknown OS, please update setup.py. So let me search this into my code spaces. So install hash lib into code spaces GitHub. Let me see if we can search uh, for a way to solve this problem. So unknown auth. Maybe we can just copy and paste this error. Unknown to verify setup.py. But this is from virtual meta, blah blah. So yeah, this is what I'm looking up. So sign hash like gives syntax error missing parentheses got string. I need simple hash function to password blah by chance, blah. So hash like is the standard library now. That means you don't need to install it. There's oh, I see. Didn't know that. All right, so it is on a standard library and I don't need to install it. Great, that sounds great. So let me see if we can run our Python, like the function that we needed. So from the hash slave, let's bring secret message that hash slave. No, I think it was hash slave. Is even detecting it? I don't know. Yes, if you want to add a blah blah. All right, so let's see the Python documentation of the let's look up at how it was all the SHA 250 that we are looking at. So SHA to okay, so first we import hash type. So after importing okay, so then update, nobody inspects, and we can print it out. So hash lib, all right, so let's see if this works like that. So hash lib that SHA 250 to 56 and secret message. And let's see if this works. And if it doesn't, let's see how we can solve this. Python main.py strings must be encoded before hashing. Okay, so should we first okay, so m.op that exegest. All right. So to be honest, I don't know what this B means. So let me ask ChatGPT how does this mean. So let me ask, what does the B in the function mean? Following function in, and let me copy and paste this, the m.update or all this. Mm, copy and pasting it. Hexagon. All right. I think everything should be on. Mm, all right. So in Python, the prefix before a string literal indicates that the string should be created as byte object rather than regular string. All right. Yeah. So we use the byte. All right. So in the given example, being about inspect the Spanish repetition is byte literal. Bytes literals in Python represent sequence of bytes, which are commonly used when working with binary data, and we're interacting with certain libraries or APIs that expect data in a specific binary. All right. So, the function bytes, object. All right. So it takes, all right. So let's look up at this into the documentation. So it's 256 to see what are we expecting to receive. Hash algorithm. Here's one construction method named I return the hash object with the same simple interface. For example, use All right, so you can now fit this object with byte like. All right, so it's byte like object. So we're expecting to receive a byte like object to update it, right? So you can now fit this object with byte like object now byte using the update method. At any point, you can ask it to digest the concatenation of the data fed with using digest or hexadecimal method. All right, sounds good for me. So let's see if we can work with that by just adding B, and I think for using this, we can use simply no, I think it was like this. Use secret message. Let me see if this works. How can I use a little? I thought I can use. So if instead of using the, so if can I use instead of look variable then string in the same function. Data number inspect, data dot encode. So we first need to convert the string variable to bytes using the encode method. Okay. So data bytes is equal to data encode, and then we need to calculate it. All right. So sh hash is going to be, all right. Sounds good. So let's do that. So first we need to encode it, encoded message, and this is going to be equal to secret message, and I think it was called encode. Data.encode, yeah. Dot encode, and after that we need to use the hash, right? Hash secret hash is equal to, and then encode the encoded message hashlib dot sh8 to 66, and the encoded message. And I think that's all right. Hashlib, All right, so then we get the hexadecimal also. So after that, we just need to print. Let me put this here. Let me change it to our actual variable. So we're going to change to secret hash and then digest secret hash. So let's run this and see if this works. So a zero object analysis with encode, the human encode. Yeah, sorry for that. not defined and pose it. I also forget to write this. So Terry had dictionary argument. Oh yeah, sorry for that. And yeah, so now we are seeing the actual hex stages, like the hex version of our secret message. I don't know if we actually can print just the secret hash. Let me see if we can do it to see the difference between using the hex stages between the secret hash. All right, so if we try to print the secret hash, it's going to be a hash object, and we use the function hexadecimal to see the actual value in hexadecimal. So just let me reconfigure this here and go again and percent share the screen. And go again and type share this and add it to the stream. And now you'll be able to see everything, right? So yeah, we can continue with this. So we already saw how we can hash a string in Python. So what do you think if we continue by just looking up at what the actual common hash algorithms are, right? So there are several widely used hash algorithms, including MD5, SH1, and SH256. MD5 is a widely used algorithm that produces a 128-bit hash value. It has been shown to have some weakness in recent years. However, it's no longer considered secure for obtaining applications, for signal applications. SH1, SHA1 is another widely used algorithm that produces a 160-bit hash value. What it is still considered secure for many applications. It is also showing some signs of weaknesses. So SHA256 is a newer algorithm that produces a 256-bit hash value, meaning making it more secure than both MD5 and SH1. So when choosing a hash algorithm, it is important to consider the level of security required for the application. For example, if we are hashing passwords, we may want to use the SH256 to ensure that our attacker obtains that even if the attacker obtains the hash values, they cannot easily determine the original passwords, you know. So the MD5 hash algorithm, like we saw before, it's a widely used hash algorithm. So this is just like some history, but like we saw, we are not using right now a lot like this algorithm. So I think we're going to skip it. And I also think we're going to skip the SH1, but if you want to look up at these two algorithms, go ahead. And yeah, so let's look up at the SHA256 hash algorithm. So the SHA256 algorithm is a newer hash algorithm that was developed by the National Security Agency, the NSA, in 2001. So it produces a 256-bit hash value, and it's commonly used for digital signatures, checksums, and other applications with a strong security, where strong security is required. So unlike MD5 and SH1, SH256 has not been shown to have any significant weaknesses. So making it is one of the most secure hash algorithms available today. So when choosing a hash algorithm, it is important to consider the level of security required for the application. Like we saw before, like if if your applications need to be real secure, like using this hash algorithm should be great. All right. So we already saw like how to use the hash loop library in Python. So we can use some other things like what do you think if we go into look up on some other or uses of hashing like data integrity verification, comparison, or trace detection, and password and secure password storage. So let me just configure this again, and I'll do something like from the time the please can you me some content for Python workshop. And let me see. We'll write explanation difference. All right, so let's see if we can just look up at this data integrity verification. So let's Google what this is, right? So we were looking at this. So let me just search like what data integrity and verification is. So let's look at what it is, right? So data, all right, so I think this is enough. So data integrity is a process of verifying the accuracy and consistency of data stored in the source device. The main objective of data integrity check is to assure that backup data is valid and is kept free from unauthorized access, modification, or all deletion. So why is data integrity important? Business or personal computer users regularly back up their important data to protect from loss or corruption. Once the data is backed up, it may undergo several operations from time to time, such as retrieval from decision-making, transfer to another system, periodic updates or deletions by other users or processes. Also, depending on the storage location, external drives, remote drives, etc., and how backups are stored, encrypted or plain text, data can be corrupted over time and become useless for business or professional use. Therefore, it's not only important to focus on regular backups, but also its integrity to ensure it remains unauthorized and unaffected by viruses, hacker, or owner arbitration, right? So how we can verify data integrity? So data integrity checks is not easy to perform. If your backup program does not provide to you a convenient and efficient way to verify data stored in backup services, right? So think back to blah, 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 just like that. And right, so verify could be correctly. So all right, so let's better check this and how to use hashing for data verification. So let's read this article from Microsoft to see if we can ensure something. Verifying hash data can be compared to hash value, blah, blah, blah. All right, so a letter, with the count, just mention. Okay, so data can be compared to hash, can be compared to a hash value to determine its integrity. Usually data is hashed into a certain time that the hash value is protected in some way. At a later time, the data can be hashed again and compared to the protected value. If the hash value match, the data has not been altered. But if the values didn't match, the data has been corrupted. So for this system to work, the protected hash must be encrypted or it's kept secret from the other interested parties. So it gives to us a following example in C#, but I think we are going to pass with this. So basically, it tells us like what we already saw, right? Like, hey, if you're going to use a hash algorithm and you want to encrypt like a secret message, like I don't know, imagine this is from your password, you will need to use this to basically just encode your message, hash it, and have its value into like a 250-bit value. So if you change something into your secret message, like adding this, adding a website and run this again, and sorry for that, I think I forgot to, yeah. So if you change this and one space and run again, you'll receive something real different, like the first hash that you have. So I think even if you will change this or like try some other algorithm, the avalanche effect will still be happening, you know? So yeah, like we saw, basically it is a security thing, like security concept that we need to know, or like hashing helps us to detect if some data has been altered. So another cool thing that we can or like we can search is what file compression and change detection is, or what called how to or like how to use. Maybe even we can just ask like how to use hashing to for file compression, data detection, how to do so well, everyone is really C# lovers, so cool. So what about this? Sometimes you need to figure out if you can do the file different, then maybe write an event. So maybe you can use the like property field So let's say you're working with blah 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 blah. And okay, so I think in this example it has chicken, blah 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 blah. Yeah. Let's see on our page if we can like check something better. Let's use hashing for in Python. So okay, this looks cool. How to compare two files using hashing in Python. So in this article, we'll be creating a program that will determine whether two files provide state or not. By the same means, they're considered blah blah blah. So first install Hashleaf, then we're going to have a file, and we're going to have another file. We're going to hash these two files, I think. So let's see what this code does. So first we have our hash file, blah blah, buff size, So we have a buff size. Then we're going to initialize our hash.left. We open the file. Okay, so while we not reach the end of the file, so we are going to read our data. If there's none data, we're going to update. We're going to break. But if not, we're going to just update this, and then we're going to return the hex value. So we'll have our first value, our second value hash. So both files are the same. All right. And files are different. All right. So let's see what this does in the comments. So first, we read the data, both sides files saving the variable. So passing that data to the hash function, update function, and hashes all the input data passes the object and finalize method, after which all the input data gets blah blah blah. All right. So let me see if there's another value that can help us to do this. All right. So for same file size input. All right. So maybe we can ask ChatGPT the same thing to really understand how this is working. Let me go here. I'm gonna share my screen right now. Let me hide the sidebar, and now we can ask ChatGPT. So how can I use blah blah blah. Go to the end, and in Python, let's see. In Python, you can use hashing to compare files and detect changes by computing and comparing their hash values. Here's an example of how you can use hash to achieve this. So we're going to first import our hash link, then we're going to create a function called calculate file hash. We're going to bring that as an argument the file path and the algorithm that we want to use. In this case, you're going to use the SHA 256 algorithm. So we're going to calculate the hash value of a file using the specified algorithm. So we're going to use the hash object. We're going to create a new SHA 256 algorithm. So we're going to open our file. So after opening our file, we're going to traverse our file. So we're going to read all the data in chunks. So if there's no data, we're going to just break. But if not, we're going to just update our hash object that is going to be like appending new values for each character that we're reading, or like for all the chunks that we are going to read. And then we're going to return the hash object, or like the hex digit value of our hash object that we just path, and then we're going to compare the two files that we're going to have. So the first, we're going to pass, well, we create a function called compare file, so it's going to receive file, two paths of the file number one and the file number two, and we're just going to compare the two files by calculating the hash value of the first file and the hash value of the second one. Then we're going to compare um, the value of our hashes, and if they are equal, we're going to just print files are identical. But if not, we're just going to print files have changed, right? So there's a so yeah, we just pass the values or like the paths of the files that we're going to use, and then we run the function of comparing the two files. What if you think if we copy and paste this into our code spaces page that we've been using? So let me go here and blah, blah, blah. Let me delete this again and let me comment this. And yeah, now we should be able to do all this. Let me comment this again. Yeah, I think we should be ready to go. Let's create another file like, I don't know, maybe like hacktext.txt, and I don't know, hacker.txt. And the first one is going to be to say something like, I like cuddles. And the second one is going to say hello world. And let's just compare the two files. So the first path is going to be the hacker.txt file, and the second one is just hacktext.txt. Then we're going to compare files. Calculate file path. Algorithm is so we first create a hash object. It's going to be a new SHA 256 object. Then we open the file path. In this case, it's going to be this one. Hacker.txt. We open it, then we read the data in the file of the file in chunks. So let me ask ChatGPT if he can explain this line better. Can you, let me share the screen also, and can you explain a little bit more what those three lines mean? So, all right, so let's bring down the line. So this line, of course, we're reading data from the object file in let's read method. So in this case, we're reading 4,096 bytes at the time. The value represents the chunk size of the first size. It determines how much data is read from the file in each iteration. You can adjust the value based on your specific requirements. Small chunk sizes may be suitable for memory constrained environments or when processing very large files, while larger chunks may optimize our read performance. The read method returns the content of the file as a byte object. That means that data will contain a chunk of binary data from the file up to 496 bytes in the case. The loop continues to read the process data from the file until there is no more data to read, so which is indicated by the empty data value. All right, so by reading the file in smaller chunks where you can efficiently process large files without loading the entire file into memory at once. So this approach is particularly useful when calculating the hash of large files, as it allows to process the file in manageable pieces. All right, so let's see if we can do that. So, then we just then we say if we have reached the end of the data, we are just going to break. we'll update our object data, and then we're going to return the value of our hexadecimal hash object. And yeah, then we create a function of comparing the two files, have the file number one and the number two. Then we calculate the hash of each one of the files by the previous function. And by then we just compare the values and return if they're identical or not. And then we just use the, like, declare the paths or the names of our files. Then we run the comparing files, and let me see if this is going to work. So files have changed, yeah. So they are not identical, but let's look if we put electoral into the other file, if this is going to be the same. So yeah, files are identical and files have changed. And let's see if this is true by just printing out like the values of both hash values. So let's print file one. I don't know if this returns calculate file hash. Yeah, file one hash and the file two hash. No. All right, the file two hash. Let's look at both of them. So yeah, as you can see, we have both of them are identical, but if we add a white space into our file, I don't know if this is going to be the same. So yeah, styles have changed, and this is really cool because as we saw, like we're seeing like the avalanche effect. Even if we have just a white space, the hash will be different. And let's look at it by just copy and pasting this. And and yeah, like, as you see, we have different files because we just add a white space at the end of our file text. So yeah, you can see the avalanche effect is running, and it is really cool. So you can ensure that this is the SHA 256 algorithm is one of the most secure algorithms that you can use for hashing. And as you saw, it is really secure. It can help you to hash important data that you have in files, like maybe, I don't know, if you're using a database that has a JSON that has the password of your client or something like that, you can use it to secure the password of your clients and then just secure them. So yeah, we have reached 1 hour. So why do you think we take a 5 minute break to take a little bit of water? So yeah, so actually, let me share with you their repository. So Alex is asking if we should have the code. So yeah, you can have the code. Let me share with you the repository. Thank you for call security week. Oh well, let me see the share GitHub. Security week. There you are. So you can see, let me make the command like we saw yesterday. Making commits into code spaces are really easy to do. So you just need to stitch all your changes by making a click to this button in the changes that you made into your commit. So just stage all your changes, add a commit message like learned, like, I don't know, hashing is down, or like hashing down, and emoji, like a thumbs up. And you just need to confirm that the changes are done and synchronize the changes, accept, then go to your GitHub account, refresh your GitHub repository, and I think now you'll be able to, yeah, now you're able to see the changes. And let me share with you the path of this, like the link. So I've already shared with you the URL into the Global Hack Week, into the chat. So yeah, you can access to it. So what do you think if we take a 5 minutes break and then we return? So I'll see you everyone into 5 minutes. Hey everyone, I'm back. Um, with the pause music. So, hi everyone, we're back. So let me share again. Let's continue and now learn. We already learned about hashing, but we have not learned anything about encryption. So let's start with the presentation. So if you're asking which is the name of this page that generates a quick presentation with AI, it is called Tone.app. And you can use it to use school, in college, wherever you want to use it. So yeah, so let's start with this. Unbreakable fundamentals of encryption. We're going to learn about introduction to encryption, what is encryption, types of encryption that exist, encryption in practice, and challenges of encryption, and well, the conclusion. All right, so let's start with this. So encryption is the process of converting information into code that is difficult for unauthorized people to read. It is an essential tool for protecting sensitive data such as financial information, personal data, and trade secrets. So with the increasing amount of data being transmitted over the internet, encryption has become more important ever than ever. You know. So in this presentation, I will explore the fundamentals of encryption, including what it is, how it works, and different types of encryption, and how it is used in practice and challenges that it poses. So for this, let's start with first, what is encryption? So encryption is the process of converting plain text into ciphertext, so which can only be read by someone who has the key to decrypt it. So the key is a mathematical algorithm that is used to transform the plain text into ciphertext. So basically, we no the mic. Um, hello. Can you hear me right now? Uh, let me know if no. I see. It's my internet. Sorry for that. Sorry for that. So sorry for that. So sorry. It's my internet connection. It's yeah. A stranger told me that I'm having some problems with my internet. So sorry for that. I cannot control it. Right. I don't know what the internet today decided to be real bad. So yeah, sorry for that tiny text. And sorry for that scandal. And sorry always. And sorry everyone please in the stream right now. So yeah, let me know if now you can hear me well or if it is still glitchy or if I'm still having some problems. But yeah, let's start with this. So, as we were saying, the key is a mathematical algorithm that is used to transform the plain text into ciphertext and vice versa. So the strength of encryption depends on the complexity of the algorithm and the length of the key. So for example, when you send an email, the message is encrypted before it is sent. The recipient then uses their private key to decrypt the message and read it. Without encryption, anyone could intercept the email and read its content, you know? So yeah, so there are a lot of types of encryption. So there are two main types of encryption, the symmetric and the asymmetric. So the symmetric encryption uses the same key for both encryption and decryption, while the asymmetric encryption uses a different key for each process. So symmetric encryption is faster and simpler, but less secure and asymmetric than asymmetric encryption. So asymmetric encryption is more secure because the private key used for decryption is never shared, but it is slower and more complex. Another type of encryption is end-to-end encryption, which ensures that only the sender and recipient can read the message, even if it is intercepted during transmission. So encryption in practice will be something like I don't know, like an example will be banking, e-commerce, email. It's also used to protect sensitive data such as medical records and government documents. Many companies use encryption to secure their networks and prevent unauthorized access to their data. For example, when you enter your credit card information into an e-commerce website, the information is encrypted before it is transmitted to the server, and this prevents anyone from intercepting the information and stealing your um, card information, you know. But there are a lot of changes, a lot of challenges into encryption. So while encryption is an essential tool for protecting sensitive data, it is it also poses several challenges. One of the big challenges is the key management, which involves security storing and sharing keys. If key falls into the wrong hands, the encrypted data can be compromised. So another challenge is the balance between privacy and security. Governments and law enforcement agencies argue that encryption can be used by criminals to hide their activities. So while privacy advocates argue that encryption is necessary to protect individual rights and freedoms. So, so yeah, I think this was like an introduction to encryption. It's an essential tool that we all use, even if we don't know that we're using it. Like in the emails, to be honest, I didn't know that all the emails, like all the emails were encrypted. Like anyone else, like without it, everyone can see my emails or who I'm emailing to and things like that, you know. However, it also provides to several challenges such as the key management and the balance between privacy and security. So as individuals, we can take steps to protect our own data by using strong passwords and also factor authentication and being cautious about sharing personal information online. By doing so, we can help to ensure that our data remains secure and protected. So cool. Now we see now we've seen like the introduction to encryption, but how we can use it in Python. So I don't have the answer for that, but ChatGPT does. So so yeah, let's just ask ChatGPT if he can give us an example of how to use encryption in Python. So can you give me an example of how can I use encryption in Python? So let's see what does this give to us. And also, please let me know if you're still hear me bad, if I'm still have a lagged sound or anything like that. So yeah. So let's see what this ChatGPT tells us. So certainly, here's an example of how you can use encryption in Python using the cryptography library. So from cryptography.fernet, import fernet. So we first generate a key. So okay, this should be an object. But yeah, so we generate a key, we encrypt the message. All right, so let's see if let's ask what fernet is. So what fernet is in the code? Because I really want to know what the fernet means. So in the code, fernet, so in the code example, fernet refers to a class provided by the cryptography library in Python. Fernet is an implementation of symmetric encryption using the symmetry cryptography algorithms from the advanced encryption standard family. The Fernet class in cryptography simplifies the process of symmetric encryption by providing a high-level interface. It handles encryption and decryption operations using a symmetric encryption key. Here's a brief overview of the Fernet work. So when you create an instance of the Fernet class, you should pass the secret key as a parameter. This key should be a 32-byte URL safe-based 64 encoded string. The Fernet instance uses the key to initialize the encryption and decryption algorithm. The encrypt message, you call it the encrypt message, blah, blah, blah. All right. So the cryptography library offers many other cryptography functionalities beyond Fernet. Sounds good. So let's read the example. So first we generate the key and we return the key already generated. Then we declare the function encrypt message that receives a message and a key as a parameter. So this function encrypts a message using the provided key. So we initialize an object Fernet with a key. So the encrypted message should be the message encoded. That the message is basically the message that we send as an argument. So we encode this message and then we encrypt it, and it stores into a variable called encrypted message, and then we're going to return the encrypted message. So after that, we declare the function decrypt message that receives the encrypted message as an argument and the key of the encrypted message as an argument too. So this function decrypts encrypted message using the provided key. So we again initialize a Fernet object with the key, but we are going to use this Fernet object with the key but for decrypt the message. So we pass the encrypted message to the decrypt function, and we're going to receive the decrypted message here, right? So then we're going to return just the decrypted message. So next example should be encryption key is going to generate first the key, and we're going to encrypt the message that is going to say help, this is a secret message. So the encrypted message is going to be encrypted, and then we're going to pass the encrypted message, and then we're going to see the decrypted message. So what do you think if we copy and paste this code into our GitHub code space? And let me just, again, comment this here and comment it this way. Oh, well, let me just comment everything here. You can see. And now let me go again and do this here. So we're already imported. So I don't know if we need to install this, but let me do it. So pip install cryptography, or let me Google also if or even we can just ask ChatGPT if we need to install it. Should I need to install the cryptography library in Python, or it is a base library? So let's see. It's not the base library in Python. Means all right. So we need to install basically. So let's install it. So install cryptography, and it's already downloaded. So let's see if this is going to work. So sorry for that. All right, so let's just clear this. Clear, and let's run this again. So the encrypted message is a really long message with a lot of random things. All right, to be honest, I don't really understand how this is being generated, but I think I should not rectify for that. So yeah, basically we are going to pass this, and maybe I don't know. We can even just try to encrypt this data and try to compare it to see if it is equal, or to maybe just keep it secure. And what I really want to see is like how our key looks like, right? Because we first generate a key and it's going to return us a key. So let me see if the key that we receive is something like an object, or if it is just a string or something like that, you know? So let's print key and print our encryption key. Let's look at how does this look. So yeah, actually the encryption key is actually a byte object, byte-to-byte object, as we saw on the hashing part. And also the encrypted message is a byte-to-byte object of this. And it is really long. So yeah, our key is also really long. So what I want to know is what does actually this function does, the generated key, for the Fernet that generate key does. So let me ask ChatGPT what does this does. So can you explain a little bit more what does the function does? So Fernet generate key function is a method blah blah provided by the cryptography. Blah blah. Here's how. So when you call Fernet that generate key, it generates the new random encryption key. It is a 32-byte URL safe base 64 encoded string. And that is really specific, to be honest. So the generated key cryptographically secure, meaning, sorry for that. So meaning it is generated using a cryptography strong random number generator. This ensures that the key has a high level of randomness and it's difficult to predict or guess. So the key generated by Fernet is suitable for use when fairness clause and the symmetric encryption algorithms support. All right. So after looking out at this, let's see if we can just let me look up at something because I forgot. Blah, 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 All right. So we already saw an example of symmetric encryption, but let's ask ChatGPT if he can give to us um, an example of asymmetric uh, asymmetric encryption in Python. So let me ask ChatGPT, um, can you give me some examples of the following topics in Python? Okay, so so the overview of asymmetric encryption concepts. So the symmetric encryption it is, as we saw, it uses a key for the encryption and for the decryption rather than the symmetric that only uses a key for the decryption. So asymmetric encryption uses the, well, no, it, I mean, the symmetric encryption uses a key for the same key for encryption and for decryption, but asymmetric uses two different keys for each process, right? So a different key for each one of the processes. So asymmetric encryption uses a pair of keys. So a public key for encryption and a private key for decryption. The keys are mathematically related, but it is computationally insensible to the private key from the public key. The public key can be freely shared with others, while the private key must be kept secure. So the RSA is a widely used asymmetric encryption algorithm. It's an example of how we can generate RSA key pair using the cryptography library. So we're going to use the same library that we already saw, the cryptography library, but now we're going to use some sub libraries like HouseMap. To be honest, I've never seen this in my life. So let's just try to figure out how does this work. So we first generate an RSA key part. So it is going to be RSA dot generate private key. We're going to have a public exponent and a key size. Yeah, so someone asked, how do you comment a whole section out like that? And all right, so this new chunk is going to be updated until we finish the hour, I think. So I'm going to commit it into the repository, but if you want it right now, let me just give it to you right now. So let me just commit this and what is that? This is for symmetric encryption, and also a thumbs up. Seeing the changes, and everything should be ready to go. Let me share the story, update it, and symmetric. I think it is updating. Yeah, hashing is down. Yay. So we updated the hashing down. I mean the symmetric encryption. So cool, everything is done. So now you should be able to see the new code that we just saw right now. And you were asking if about how can I comment all this chunk of code with just like that, right? So you want to press Control K and C, and that'll be it. If you're using a MacBook, I don't know. I think it is Option KC or something like that. I'm not using a MacBook. I'm using a Windows OS computer. So yeah, that would be. But yeah, I think it's Option KC or Control KC. So yeah, I think that should be it. And with that command, you'll be able to comment the whole chunk section. So yeah. And yeah, now we're seeing this. So the private, we first are going to generate an RSA key pair that is basically generate first the private key. Sorry for that. So by generating the private key, we're going to generate it. We're going to have a pull exponent and a key size. And after that, we're going to have a pull key. That basically it is just generate, pass the public key of our private key. I don't know where does this come from. Okay, I think this returns like an object, and this object has a public key ultimately. So we're going to just use that public key, and then we're going to serialize and save the private key. So I don't know what does this mean. So let me ask you what would serialize mean. So when you're talking about serialize and save the private key, what do you mean with serialize? So when talking about serializing a private key, we refer to a process of converting the private key object into a standardized format that can be stored and transmitted. In the example provided, with the private key is serialized using the PIM, privacy enhanced mail format. The PIM is a widely used standard of repeating cryptography objects, including private keys and certificates, in human readable and machine possible manner. So the serialization of process involves converting the private key object into a byte string representation that follows the specific format rules of the chosen serialization format. In the case of PIM, the private key is typically encoded in base 64 and enclosed between some lines between private key and private key delimiters. Sorry for that. So by serializing the private key, we want to make we'll make it possible to store it as the file or transmit over the network, and it allows us to easily recreate a private key object from the serialized representation when needed. So the cryptography library provides the serialization model, which includes functions for serializing and deserializing cryptography objects like private keys. In the example, the private key private bytes method is used to serialize the private key into a PIM encoded byte string, which there is written by using OpenWrite. All right, sounds good. So, where we are, yeah. So we first serialize and say the private key. So we use the private bytes method of our private key object, and then we use the PIM format that we were talking about. So we first encode it, and then encoding is going to be the serialization of the PIM format. We use the encoding that PIM format variable of our serialization variable. So where is those? Oh yeah, so serialization basically is just like a function or an object that we're going to import. So we're going to use also we're going to specify the format. The format is going to be the serialization private format that PKCS8. So encryption algorithm is going to be non-encryption, and then we're going to open a file and we're going to create a private key into we're going to write a private key into a new file, and we're going to secure the file, and then we're going to serialize a public key. So yeah, I think this basically ensures that you're going to have security into your RSA private key and secure and now because where you can share and allow others to see your public key, you won't need to worry about that. So that's we do a lot of random stuff here, like to secure our key. And in the example, we generate an RSA private key with a key of 2048 bytes and a public exponent of 65 537. The private key is then used to derive the corresponding public key. The keys are then serialized to the PIM format and saved into separately files. Alright, for the private key and public key PIM for the public key. So, alright, that looks good. So let's see if we can use this into our code space. So let me see if we can use this, and let me import this right from the top. And that should be it. And where does the, oh my god, I don't know why this is here. So let me put this right here. Right, so I think we should be it. So is this already commented? No, this is not commented. So let me comment all of this again. And again, Control KC, and now you can comment all of your code chunk. And let's just try to do this and see what does this returns to us. So it should create two, yeah, it should create two private keys, and it created a really long private key and a public key that we're going to have. So yay, we are ready. We created our first synchronous encryption. So congratulations, we have already a public and a private key, and we have used encryption to encrypt some keys for, I don't know, maybe you can use it for your cloud or for your VM or for your password, things like that, you know? So cool. Now let's see another example of encrypting and decrypting data using RSA. So here's an example of encrypting and decrypting data using RSA. So yeah, so we first start again, we're going to use the same RSA algorithm. Then we're going to use the serialization. So first we're going to load the private key. So with open private key, we open the file, and we're going to serialize it again and then load it. We're going to read it, and after reading it, we're going to see, we're going to encrypt our data. And after encrypting our data, we're just going to, let me see, encrypt data is in the public key. We have a data held, this is a secret message. Ciphertext is equal to public key that encrypts data, padding, blah, blah. Wow, this is a lot. I don't know what does this mean. So let me ask ChatGPT what does this mean. So can you explain a little bit more and the following lines? Ciphertext. And I think this should be able to go. So simply, let's bring down the comments on how. So this code maybe we're encrypting data using RSA public key. Public key decryption is performed with a padding scheme called OAEP, optimal automatic encryption padding. Here's the breakdown of the code. Padding OAP, and this line creates an instance of OAEP. Padding is sham from encryption. OAP provides weight and provenances to additional security, blah, blah. And MF padding algorithm hashes. The MGF parameter stands for mass generated function. In OEAP, a mass is generated using a cryptography hash function. Here we specify that the MGF1 mass generated function 1 is used with SHA 356, the underlying algorithm. So the algorithm parameter specifies the hash algorithm used for the encryption. In this case, we use SHA 256 for both the MGF1 mass generation function and the underlying encryption algorithm. So level known, the level parameter is an optional parameter in the OAP. It can be used to add additional context or information to the encryption process, but here we set it to none as we don't require it for the example. So the ciphertext is going to be equal to public key encrypt. How this line actually performs the encryption, the encrypt method of the RSA public key. It's called passing in the data to be encrypted, and the OAP padding scheme is created earlier. The result in stored ciphertext variable which holds the encrypted version of the data. So the result ciphertext contains the encrypted data which can be secured, transmitted, or stored, and the only corresponding private key can decrypt blah blah blah. So to reiterate, basically it does a lot of it creates a lot of mask that uses some cryptographic hash functions that allows us to make it more secure and encrypt our code to make it secure, you know? So yeah, let's continue. Okay, so we add the padding, we make it secure, then we decrypt it by using our private key, and we use the function of our private key object. So we pass the ciphertext and pass the padding, and this should return to us the unencrypted data. So let me just copy and paste this, and let me update it here. And let me copy and paste this here, and let me again comment all of this. Control P C, Control C, and paste this again. And I think I need to add the padding. Padding, and I think this should be it. Yes, I think this should be it. So let me see if this should work. Right, so let's run it. Ciphertext will be created. The public key is not defined. Oh yeah, because we public key was oh yeah, we need to generate this. So to uncomment the commented chunks of code, you just need to do Ctrl K U to comment, and I think this should be it. So we do a private key and a public key, and hashes not defined in hashes. Let's ask ChatGPT where this hashes comes from. So this hashes comes from another part. In this line of in the line of where does hashes comes from? The hashes model and cryptography library provides various. All right, so we need to import hashes from primitive. So let's do that by just going to the top, primitives, and add hashes. And let's see if I need to put something more. So, all right, so what is going on? We have an error. All right, so let's see what is going on. So, blah, blah, blah. Right, so encryption failed. Right, so we first look at the private key decrypted data, private key decrypt in ciphertext. What does ciphertext mean? I think we don't even have ciphertext. I think we need to add the ciphertext equal to. No, we have ciphertext here. So with public key encrypt the hand data, padding blah blah blah. Decrypted data, ciphertext, blah blah blah. So what is going on? let's ask ChatGPT again. So let me add another chat and use the GPT for value. So can you find the error in the following code and pass the code that we have here. Go to the start and all of it, and specify the Python call, and just pass it like that. And the problem with your Python code is that you're trying to input data using public key, but public key is not finding where you can. Oh yeah, I forget that. Did I forget to? Yeah, let me edit that because yeah, I kind of forget the public key and the public and the private key, right? So let me pass this. And just save and submit. There in the Python code you provided lies in the processing of generating and loading the area's private key. Here's how it works. First, you generate private key and corresponding public key. The public key is derived from the private key, and at this point, both keys are stored only in memory. Next, you try to load the private key from a file named private key, but as you haven't saved the generated private key into the private key.pen file before this step, it causes a problem. The program will load whatever key is currently in the file if it exists or raise a file not found error. So in order to fix this error, you need to write the private key through the private key.pen file just after it's generated. How to do it? So we do the same thing. Save the private key. Load the private key. Please be aware that this code as it's designed is not suitable for a real-world application, as it doesn't include any protections against many potential security vulnerabilities. The key storage is one area of concern, as anyone with access to the file system can read and write the key files. This could allow an attacker to steal your own key, potentially giving them the ability to read altered data. Yikes. So yeah. So I think for now, we should be able to do it right now. So let me just try to paste this and see if it works. Try to delete this and it in this way, private key, and I think we just need to put this. And well, I mean, why don't we change the open and the private, right? So we, all right. So let me just clear this. And after clearing it, we're going to modify the loading of the private keys and all this stuff, you know. So we're already commented this. We're going to pass this like that. So then we're going to pass this as this. And let me format the document. Should I need to format? No, I think I don't need to format anything. So decrypted data is not defined, blah, blah, blah. All right, so what is decrypted data? 134. Oh, yeah. So we will allow the private key. First, we generate the RSA key pair. Then we save the private, and then we load it. And after loading it, I think we now should be able to use it in the model. So let me just encrypt them and encrypt the data by copy and pasting this. Copy, paste. What's going on? Should copy and paste this. And yeah, we generate the sector, then we set the private key, then we load the private key. And after loading this, we now create our data, our secret message. Then we create the ciphertext object that is basically the encryption of our secret message. After doing this, we're going to decrypt it and we're going to bring the encrypted message. So, yay, it works. It actually works. Awesome. We did it. So let's try to understand this a little bit more, right? So first, generate the RSA algorithm key, private key pair. So the only key that we're going to share right now, because it's the only one where you're seeing it, is the private key. So after using this private key, or well, after generating it, we're just going to save the private key. Then after saving it, we're just going to load it. And after loading it, we're just going to create our secret message, and we're going to transform our message from bytes into a ciphertext. Like as we see, ciphertext is a lot of hash functions and secure functions and algorithms, hash algorithms that are going to transform our bytes into something real different that we can use for encryption. So after doing this, we're going to encrypt all of our data. It basically is our secret message encrypted into a lot of things like we're going to pass the message that we want to encrypt and the algorithms that we are going to use. We're going to use the OAEP standard for doing all these algorithms, and we're going to pass the hash SHA 256 algorithm to hash it or to help it encrypt our message. And then we're going to decrypt our message. And after doing this, we're just going to with our private key, and then we're going to decrypt it. We're going to decrypt it by passing the ciphertext and passing the key of our decrypted or like our encrypted message. And after doing this, we're going to just pass this, and we're going to decode it, and ta-da, that should be it. So cool. I think we'll learn a lot of things right now. So let me pass to you the code here. So I think from what's the synonym encryption? I think it was right. Asymmetric encryption. So symmetric encryption and the like. And that should be it. So now we should stage all of our changes, then we can confirm, and then we sync our changes, accept, and let's go to our repository to see if the changes have been committed. So yeah, asymmetric encryption is now done. Now you can go into our repository and download the previous code. So yeah, let me know if you have any kind of question. If you have any kind of specific questions, like some topics like the OAEP format or things like that. To be honest, I don't know anything about this, but we can go with it. We can learn a lot, and we can ask ChatGPT how to do this, right? So if you have any questions, you can make them right now. And if not, I think this should be it. We'll learn some basics of hashing, how to use hashing, how to use hashing in Python, some use cases of hashing, like comparing some passwords, comparing if files are equal and things like that, you know. And I think we also, well, learn like some hash algorithms like the MD5, the SHA 256 one, and we also learned about the types of encryption, what encryption was, fundamentals of encryption, and some use cases of encryption, like where do we use the encryption into, and yeah, I think we covered a lot into this session. So I think we'll be able to finish our session on the next session that is basically tomorrow in, I think it was, let me search again the hour. I think the hour is like 9 ET or something like that because this was on 11 ET, but the previous one, well, the next one is going to be at 9 ET. So be prepared. We're going to learn a lot. Let me see what we're going to learn because I don't have. We're going to learn about secure communication and SSL and TLS, some best practices for security configuration, and a wrap up and a Q&A. And I think that should be all for the session of fundamentals, or like learn how to use Python for encryption, or how to use Python scripting and things like that, you know? So yeah, maybe we can do something else after finishing our session. And for today, that should be it. And I'll see you tomorrow. So have a nice go ahead week, and don't forget to register into the link that I sent to you in Discord. So let me copy and paste this. And, oh my God, I think I sent the whole message. So for that. Yeah. So it's just this one. Sorry for that. Just dazzling and organize. Just register. Keep keep farming those points, and I'll see you tomorrow. So have a nice day. Bye.